So part of my question was that just to from your experience and the work you've done so far, um, what is there a bandwidth or a range of recycling efficiency have you from a cell that was freshly made, manufactured, and was working, and we have you have gone through the process, you've done the testing, you have ascertained all the materials and everything from a overall recycling standpoint, how much is usable post that? Let's say that you do go for recycling, what is that efficiency usually?
Yeah. So let's consider an example of around one battery from four wheelers. So once we are getting the battery, so after testing, around 80% of the cells are can be used into the second life battery manufacturing, and 20% can be sent to the recycling. So this is a percentage dividation of the new the used battery pack which we right now we are having a data. But yeah, if you talk about the two-wheelers and three-wheeler battery packs mainly in India, so major players in the Indian, because A grade cells India can't afford in terms of mobility of two-wheelers and three-wheelers. So if we talk about two-wheeler, three-wheeler battery pack, majorly 20 or 30% battery can be used again. Right. So this is the, and even 70%, 60% battery are going for the recycling, because the battery packs which India is using, I think the cost is right now, new battery pack cost is around 10 rupees per watt to maybe 12 rupees per watt. This is the cost which is going on into the market right now. So already the people, the A1 grade cells, that means China, what it is doing, China is having three grade cells: A1 grade, A2 grade, and A3 grade, based on the material. So that means China is playing something that, okay, whatever the cost you are taking on the basis of that cost, they are giving the battery. So majorly right now India is not into the stage where they can afford the A1 grade batteries into the market. But yeah, to compete with the lead acid, we have A2 grade cells where you can utilize into the battery packs for two wheelers and three wheelers. Majorly because two wheelers and three wheelers don't need a higher current to drive it, but for four wheelers especially, you need a very a very quality cells to run that vehicle, because that is something where that needs a very high energy to run it. So majorly right now, if we compare our data, the thing is that first you should have a process to process is fast, because the volumes which you are going to increase, that is a very high volume. So because you have to dismantle the cells, once you have received the work, there are a lot of cells which you have to process. So you cannot go for capacity testing for all the cells. So here we have created some process where you can process almost maybe 5,000 cells per hour. So that is the capacity which we have made for the sorting of the batteries from one the battery we have received. So here mainly you can see the thing is that first 80% of the energy can be utilized again, because if you say, let's suppose you are received one battery. So let's suppose that battery is having maybe the battery of 1 kilowatt hour, right? So after utilizing into the second life, you can again utilize the battery maybe for 800 watt hour or maybe 700 watt hour of energy can be again given to the battery based on the DOD. Because the state of health, if you talk about the state of health, or the state of what we call depth of discharge. So what we are doing is we are minimizing the depth of discharge into the battery, and that's how the second life battery goes on, because mainly the lithium ion battery works on above 90% DOD. But when we are going for the second life, we are reducing the DOD of the battery, maybe you can say 80% or 75% of the full battery DOD which we are using. So in that way, we are segregating the battery, and now it's few of the batteries right now we are receiving from maybe e-rickshaw, maybe two-wheeler right now we are receiving. So 50% of the batteries can be reutilized again. So that is the whole breakage which we have given, seen till now.